Hey guys, last time on 5.2 we talked about substitution in integrals. So let's remind ourselves of some rules and how to do it, okay? So before we jump into the concept of 5.3, here's are the basic rules that we use for integration. Basically, it's just like a reciprocal or like the reverse version of what we learned about the derivatives, okay? And then this one in here is a general power rule that we learned from the last time. If you want to think about it, the x's can be like canceled in here, and then that leaves us with the integral of u to the n power du. Okay, and this one, how can we use substitution in integrals, right? So here's like the 5-step, so that we can learn how to use in substitution in integration. Okay. And if you want more example, let me know. I mean, you can definitely Google it. There's like plenty of examples online on Google and YouTube, and every problems has some like difference, but yet some similarities, right? So everything would be like similar, but then different than each other. Okay. And then let's talk about 5.3. So the first objective today, we're gonna talk about how to use the exponential rule. Okay. So we learned that from the last time the derivative of e to the x is itself, right? And then if say we're gonna have some function, say in pink in here, if we don't have x as a power, then we can have something like, I don't know, e to the 2x plus 1 in here, where the power in here is not x but is 2x plus 1, right? And because the power in here is not x, that means we have to apply the chain rule if we want to take the derivative of this function, okay? So then the derivative of e would be itself, right? So we just copy and paste this function down really quick in here, and then chain rule apply. So we have to take the derivative of 2x plus 1, okay? And let me put it in, I don't know, blue. The derivative of this function, or this power in here, is 2. So then to find the answer in here, it would be 2e 2x plus 1. Okay, and let me box it right here. And the other one, the answer is just going to be e to the x, because if you want to think about it, the derivative of x, the power in here, is just 1, right? So anything times 1 is just going to return itself. That's why I'm not going to rewrite 1 in there. And I'm not going to like do the whole process of multiply with 1 to return itself. Okay, but the idea is that. So in terms of integrals, the reverse procedure, we're going to do the same thing. The integral of e to the x would be e to the x. But remember, whenever we do the integral, we're going to have a family, right? We're not going to have just one function. They're more than one function. They come in the family, okay? So then in here, we're going to have a plus c. If you notice, let me put it in red highlight here. And then the plus c is really important. Make sure you remember it. Make sure you always attach it whenever we have the integral. Okay? And then in the more complicated version, when you have like some other function rather than x on the exponent, then what you're gonna do? Well, you're gonna use substitution. Okay? And I'm gonna show you guys how to do it in a minute. Okay? So this one in here is a more complicated version of the exponential rule in terms of integrals. And let's talk about how to use it by going through the first example in here. On my part, I have the integral of 8x minus a times e to the, that ugly like power in here, right? So what I'm gonna do is that, first of all, I notice that my e in here is not just, like x on the power, right? I have like a weird function on the power. So what I'm gonna do is that I'm gonna substitute for u. So I'm gonna let u, okay, let me just write, let u equals to that weird ugly power, which is x squared minus 2x plus 3. Okay, so if you remember the guideline here, I got u already, so this one I'm done with it. Step 2, I have to solve for x, right? And then after that, I have to solve for dx, right? So let's go ahead and do it really quick in here. Well, in here, I don't think I can solve for x, because, well, we have like 2 x's in here, right? Like one x in here under the square, and the other x is attached with a -2. So there's no way for me to solve for x like right here, right now. I mean, there's a way, but it's gonna be hard, okay? And I don't want to give you guys like a hard like math work in here. Okay, so let's not go through that path. Let's talk about the easy part first. Derivative part, right? So on the left hand side, if I take the derivative of u, I'm gonna have du for differentials of u. on the right hand side, if I go ahead and take the derivative of each of the three terms in here, I'm gonna end up having 2x minus 2, right? And then at the end, make sure you write dx. Why do we have to remember it? Well, to balance it out, right? Because on the left hand side I have a du, so on the right hand side I should have a dx or d something. Okay, so make sure you don't forget it, because I usually just forget it in my work. Okay, and now what do? Well, I'm gonna try to solve for dx, right? So I'm gonna get my dx. Okay, let me put it in pink, I guess. Okay, this is step 1, by the way, in red, and then step 2 in pink. Dx equals to du divided by 2x minus 2. Okay, and if you want to think about it, you can also factor out a 2, because, I don't know, it's just a habit of mine. When I see something like factorable, I just factor it out anyways. Okay, and then step 3, let me put it in green. If you remember, what we did in step 3 is that we're going to convert the entire integral into u form, right? So let's do that really quick in here. How can we convert everything in terms of u? So I go in and I have like the integral, and next up I'm gonna get 8x minus 8, and then instead of e to that ugly power, I'm gonna get e to the u, right? Because my u in here equals to that whole ugly like power, x squared minus 2x plus 3, right? And lastly, for dx, I have it equals to du divided by 2 times x minus 1, right? So I times it by du divided by 2x minus 1 like this. Okay? What I'm going to do next is that, well, I know this, that in here I can factor out an 8, right? So to save a step in here, you know what? Let me just do it now. Here, so this equals to the integral and then 8. Okay, you know what? Let me just write down on this line rather than like jam everything down. Okay, so integral and then 8 and then x minus 1 because I factored out the 8, and then e to the u times du 2 divided by x minus 1. Okay, what do you notice in here? Well, we can cancel the group of x minus 1, and we can also cancel the 8 with the 2, right? So this is like a 4 and this is like a 1 in here, right? And then after all that work, I'm gonna go ahead and have a 4 in front because the 4 is just like a constant, so I can bring it out. And then I have e to the u du, right? And based on the rules that we have in here, let me go ahead and take out the circles in here. This one, I have it equals to 4 e to the u plus c, right? And then I'm gonna convert everything back to x, which is I think like step 4 in here. So let me put it in brown. Step 4. My final answer, it equals to 4. Okay, I think I can write it on the bottom just so it's easier for us to catch up with everything in here. So step 4, we have this equals to 4 e to the x squared minus 2x plus 3 plus c, and this is it. Okay, so this is the final answer that we have for this case. Okay, so I think it's similar to what we did from the last section in terms of we just have to do substitution, and everything after that will be just, you know, plug in a formula, you cancel out the common terms, and then there you go, the answer, right? So here's what you have to do for your problem. And before we move on, let me show you guys, or let me remind you guys an own technique that we learned from algebra, or like, I don't know, like some other classes. Long division is like a big concept that we have, right? But before that, let me go ahead and take all these away so we have space to talk about the long division in here. So first of all, the name of it is long division. Okay, a lot of people learn about synthetic division. It's like coming together, but I'm gonna show you guys why we have to talk about long division in a second. Okay, but for now, bear with me. Say if I'm gonna give you like a fraction in here where the top power is bigger, is greater than the power of the bottom. Okay, so what do I mean by that? If you notice, the leading term on the top in here, it is 2x5, right? Because like the 5 in here is the greatest power. how many powers do you have on the top anyways, right? Like you have a 5 in here, you have a 3 in here, and this one, it doesn't even have any power, right? So you can disregard this one because it doesn't even have a power, right? And between the 3 and the 5 in here, obviously the 5 is bigger, right? That's why the leading term in here is the 2x fifth, okay? Or if you want 2x5, doesn't really matter for the name of it, okay? And with the same logic, the leading term on the bottom in here will be x cubed, right? So then if you compare the powers in here, if the power of the top is greater than the power of the bottom, then you perform long division, okay? And why do we do that, right? Like there's a reason to everything. So think about it when you talk about like fractions. If you remember, the two type fractions, right? Proper and improper fractions. If you're gonna have like 1/2, okay, let me change the example actually. If you're gonna have something like 3/2, well, the top in here is bigger than the bottom, right? So that means that you have to perform like divisions-ish. So you're gonna do like 3 in here and then 2 in here, and then you have a wall in here, and you ask yourself, how many times can 2 go into 3, right? And then the answer in here is like 1 times, and then 2 times 1 is like 2. You subtract them and you have the remainder of 1, right? So that means that we can rewrite a fraction in here, 3/2, as, let me put in pink, 1/1/2, right? And let me use color code in here. Let's see, this one's the remainder. Okay, so this one is the one in pink, and then the other one in blue. Oh, I messed it up. Okay, this one is the one. No, this one is the one in blue, and the other one is the one in pink. The one in pink is the remainder, and the one in blue is like the answer that you have from the top. Okay, so just to like link it together, the one coming from this, and then the other one coming from like the answer that you have. Okay, but in another scenario, say if you're gonna have like 2/3 in here, well, this is final, right? You don't have to do anything for it because like 3 cannot make it to 2, like anyhow. Okay, but if you have like a 3/2, then this is the final answer. Okay, you cannot keep it as 3/2 because it's improper. Okay, so in functions, we're gonna have the same logic. Okay, if the power of the top is bigger than the power of the bottom, we conduct the long division. Something like similar to this. Okay, but it looks like more complicated in functions. Okay, but trust me, like if you do like 5 or 10 problems of this type, it's gonna become like a habit of yours. Okay, it's gonna become like easy-ish. Okay, so now how do we do it, right? So here's like the whole solution, but let me just reproduce it just so like everyone can, you know, like can catch up with what it said in here in the solution. So first up, I'm gonna rewrite a top function on the left hand side like this, 2 to the 5th power, and then minus x cubed plus 2. But wait a second, there's something wrong with this function, right? Because the power in here, it goes from 5 all the way to 3 and then to none, right? So then I don't like that order like that. Okay, so instead of writing everything like that, well, let me space them out a little bit. Okay, so I don't have anything with the 4th power, right? So let me jam it in really quick in blue in here by writing plus 0 x 4th, because I don't have anything in x 4th, right? And then in terms of x cubed or like x3, I have 1 x3, right? Or just like x3 if you want to write down. It doesn't really matter if you have or if you don't have the 1. Okay, and next up, I don't have the 2, so let me just write plus 0x squared in blue. And I think I'm gonna need more space, so let me go ahead and move this thing a little bit right here. Okay, this should work. Okay, and then next up, I don't have anything with x, right? But I do have something with no x, which is 2. Okay, so this is how I'm gonna write it, okay? And then for the other side of the wall, on the bottom part, I have x cubed minus 1, right? Wait, this is x cubed minus 1. Okay, if you notice, whatever happens on the right side, we don't have to arrange them. Okay, but whatever happens on the left hand side, we have to arrange them. Okay, so then let me make some errors in here for like the color code. Hopefully that helps ish. So the top is on the left, and then the bottom is on the right. This one, arrange them. For the right side, it really doesn't matter the order, okay? If you missed like the x square in here, it's fine. You don't have to like list it out, okay? But if it were to be on the left hand side, you have to list it out under a 0 coefficient, okay? And I'm gonna show you guys why it's helpful in a minute, okay? So let me go ahead and move this. Okay, I don't have to move it, I don't think. Okay, so first of all, I'm gonna get a highest term on the left hand side divided by a highest term on the right hand side. Okay, so 2x fifth divided by x cubed, I'm gonna get 2x squared. Okay, so let me put it in pink in here for the result. So 2x squared in here, and what do I do after that? Well, I'm gonna multiply the 2x squared back to each of the term on my right hand side. Okay, so then 2x squared times x cubed, I'm gonna get 2x fifth, and then 2x squared times -1, I'm gonna get negative 2x squared, which is right here. Okay, make sure you rewrite them under the right column, right? Because if you multiply these two numbers together, there's no way you have something underneath of the x fourth, right? So make sure you do it, you know, like, I know it's really hard to pay attention to everything, but trust me, like, at the beginning it's really hard. I know it's tough. After a moment, you get used to it, okay? So what we're gonna do next is that we're gonna go ahead and change the side of everything. So this one will be negative and this one will be positive. Okay, and then after that, we're gonna add them. So these two cancel, and these two is gonna make a 2x squared, right? And then in here, I'm gonna get a 0x fourth minus 1x cubed plus, and then plus 0x plus 2. Okay, and next up, what do we do? Well, we're gonna follow the same procedure in here. We're gonna go ahead and take the highest power on the right hand side divided by the highest power on the left hand side, which is this one again. Sorry for that. This one again. Okay, so let me change the color for it. Let me use, I don't know, brown. Okay, so then, well, if you notice, 0 divided by anything would be 0, right? So in fact, let's not try this one out. So then you don't have to like save your work. I mean, if you want to, that's fine. And then you're gonna end up having like a plus 0 in here, and the power in here would be like x, right? But then 0 times x would be just 0. So why would we even care about it, right? So let's just throw it away from the beginning. Okay? Like that. Okay? So now let's talk about the x cubed in here. Is the highest power on the right side, right? And then we're gonna go ahead and take it divided by x cubed on the left hand side. And then after you do that, you're gonna get a -1, right? So then you're gonna do the same thing in here. You're gonna multiply the -1 to x cubed and also to 1. Okay, so you're gonna get -1x cubed plus 1. Okay. And then, before you go ahead and add everything, make sure you change the sign of everything. So this one from negative is going to become a positive, and this one from positive will be a negative. Okay? And these two cancel out, and this one you're set to rewrite as 2x squared plus 0x plus 1. Okay? And then now, move on to the next one, right? So then the highest term on the right side would be 2x squared. And then the highest term on the left hand side would be x cubed. But wait, can we divide 2x squared by x cubed? I don't think so, right? Because the power of x squared is like smaller than x cubed, right? Like x cubed cannot go into x squared, okay? So then that's a good side for us to stop, right? So then we're gonna call this whole thing the final like remainder for us. This whole thing in here would be the remainder. Okay, and then this thing in here, let me highlight in purple, would be our answer. Okay, so all of that work just to tell us that if you want to rewrite the original fraction, let me go ahead and move it down a little bit, like right here. Okay, let me take out some like arrows in here because it looks like a lot going on. Okay, there we go. That's cleaner. Okay, so then the answers in here. First of all, I'm going to go ahead and copy whatever I have in a purple highlight, which is the answer, which is 2x squared minus 1, right? And after that, I'm going to do plus. What do I do in here? Well, I'm going to go ahead and do, okay, you know what? Let me just use a calico in here. So let me write everything in like, what is it, blue in here, so then it's easier for us to catch up with our previous notation. So 2x squared minus 1, and then the other one, I think I had it in pink, right? So let me just get rid of the yellow and put it in pink like this. Okay, and then this one is like plus, and then the remainder in here would be 2x squared plus 0x, which is like 0 anyways, so we can throw that away. Like this one in here, you don't have to even like consider it if you don't want to. And then we have a plus 1, and then all divided by the denominator, which is right here. You can just copy and paste it right here. Then this is it. Okay, like this is the final answer for the long division that we're working on. Okay, and if you want to get like some reference, you can think about this problem. Okay, where 1 in here, okay, let me just highlight. So 1 in here is the same thing as this one. It's like the quotient or the answer that we have. Okay, and then the other one that we had in here is like the remainder, right? And then it's the remainder we have also for the function problem. Okay, and then the bottom in here, let me put it in, I don't know, red in here. This bottom is the same bottom that we have from the problem, and in here, same bottom. Okay, so if you need more practices on this one, let me know, because I think you're gonna see it in a final exam, or maybe even in the second exam too, but we'll see. Okay, so now let's jump into the real big problem. Okay, so then using the log rule. Okay, so we talked about the exponential rule already. It's time to talk about the log rules because they are the reciprocal of each other, or should I say the inverse of each other. Okay, so when the power rules for integration were introduced in section 5.1 and 5.2, we saw that they work for powers other than -1, right? So anything would work, but then if you have like a power of -1, it's not going to work for the power rule, right? So then how can we fix it, right? Like how can we do the integration of this? And okay, some of you guys may ask me like why it doesn't work for the case n equals to -1. So for example, if I give you something like, I don't know, the integral of x to the -1 dx, right? And then like based on the power rule, we know that we're gonna get like x, like the whole thing in there, right? And then the power rule said that we're gonna go ahead and like add 1 to the new power to get the new power, and then on the bottom we're gonna copy and paste that new power down, right? And then we're gonna have a plus c in here to compromise for the missing of the integral and the dx. But then if you notice, this thing in here is a problem, right? Because we cannot have a 0 on the bottom, and -1 plus 1 is actually a 0, right? So then that's why it doesn't work for the case of n equals to -1. Okay, and then in general, like the general power rule doesn't apply for when n equals to -1 also, because of the same reason. Okay, so integrals for logarithmic functions let u be a differential function of x, and then we're gonna have like two versions of the log rule, simple and a general one, right? So basically, whenever you have x to the power of -1, the one that we like been discussing so far, there's a like convention about that. Okay, so we're not gonna like use a power rule for that, but instead we're gonna use the log rule for that. Okay, so whenever you have like 1 over x in integrals, that equals to ln of absolute value of x. And again, it's coming in a family, so make sure you have a plus c in here. Okay, so that means that now if I give you some problem like integral of x to the -1 dx, well, you're gonna tell me the answer of this one is ln of absolute value of x plus c. Okay, it's not gonna be this, because again, we cannot have a 0 on the bottom, but this one in here comes to replace that like mystery of like having a 0 on the bottom, okay? So this is like one formula that you have to remember, okay? And in general, if you were to have like some other function rather than x, then chain rule apply. So then you're gonna have like more to talk about. But then again, you don't have to worry too much about the chain rule in here because you can do it by using the substitution, just like what we did in the last example, okay? So now let me show you guys how to combine the log rule, use substitution, and also long division into like a problem, okay? So integrals to which the log rule can be applied are often given by in disguised form. For instance, if a rational function has a numerator of degree greater or equal to that of the denominator, so say you're gonna have something like x to the 5th divided by x cubed, or I don't know, x cubed divided by x cubed. In this case, the power of the top is greater than the power of the bottom. In this case, the power of the top is equal to the power of the bottom, right? And say in another scenario, something like this, then the power of the top is smaller than the power of the bottom, right? So only the first two cases in here you can apply the long division, okay? The last one you cannot do long division, okay? And I don't think I'm gonna give you something that ugly, okay? But if I do, it's gonna be substitution, okay? So just ignore the case when you have the power of the top smaller than the power of the bottom, okay? So let's talk about how to work on the problems. Okay, so by the way, so, whenever you have the power of the top greater or equal to the power of the bottom, you should use long division, right? That's why we talked about it like earlier in the previous problem or in the previous example that I gave you. And then we're gonna rewrite whatever inside the integral, and then we start from there. And you will see how useful it is in a second, okay? So I noticed that my power in here on the top I have x squared, and on the bottom I have x, right? So 2 is greater than 1. That means I have to do long division, right? So how can I do it? Well, x squared plus 5x plus 7 will be on my left. And then on my right hand side I'm gonna get x plus 1, right? So in short, x squared divided by x, I'm gonna get an x in here. I multiply it back to have x squared plus x, or 1x if you want to be more specific about it. And I go ahead and change the sign of everything. So this one will be negative, and the other one from positive, it will be a negative, right? So then I go ahead and add them together. 5 minus 1, I'm gonna get a 4x, and then a plus 7. It's just like a carryover, you brought it down. And then next up, I'm gonna go ahead and divide 4x by x, and that gives me a 4 in here. So I multiply the 4 with the x and the 4 with the 1, okay? And again, I'm gonna go ahead and change the sign of everything. This one would be negative, canceled out. 7 minus 4, I'm gonna get a 3, right? So all of that work just to tell me that this integral can be rewrite as the integral of x plus 4 plus 3 divided by x plus 1 dx, okay? I mean, I do it fast in here because, you know, like I get used to it already, but trust me, at the beginning, it's going to confuse you for like, I don't know, first 5 seconds. But then if you keep doing it for, you know, like more problems, if you want, you can go ahead and change the numbers in here. Like the 5 and the 7, you can change it into whatever number that you want to, including the 1 in here. Keep practicing on that one, and then you will like get more grasp on it, okay? So now when you get to this one, it's pretty much like easy. Well, first of all, we're going to like use the sum and difference rule in here to separate them out. So we're going to have integral of x dx, that's the first term, and an integral of 4 dx, that's the second term. And then as for the last term, we have 3 divided by x plus 1 dx, right? Okay, so then derivative, okay, this one I'm going to take the derivative of everything. So then this one, it equals to x squared divided by 2. This one, it equals to 4x. Well, you're going to bring out a 4, right? And then the integral of 0x, or like x to the 0. No, yeah, x to the 0 will be like x to the first power, which is x, if you want to think about it like that, okay? And lastly, we have this one in here, right? So, okay, let me slow down this one a little bit. Okay, you know what? Let me just write one more step in here to make it more clear before I go ahead and jump to the answer. So this one, let me just rewrite it like this, and then in here, let me bring out a 4 like what I said earlier, and then I have a 1 in here. If you want to think about it, let's just put like, there's no x in here, and we do need the x because we have like dx in here, right? So then we do need the x, but then we don't have the x, so then you can put it as x to the 0, just so it's easier, okay? And then lastly, for the third term, I'm going to go ahead and bring out a 3. So then on the inside, I'm going to get 1 divided by x plus 1 dx. Okay? For the last one, if you want to think about it, you can use substitution again, right? So how can I substitute for it? Like, what do I do, right? Let me put it in blue. This work in here. Let me just copy and paste it. In here. Okay, this is like, you know, like outside work. Okay, so this in here, how can I do that? Well, first off, I'm gonna let u equals to x plus 1. Okay, and after that, I'm gonna solve for x. So my x equal to u minus 1, and after that, I'm gonna take the derivative of both sides. So then the derivative of x will be just 1, or like dx, right? I usually don't write a 1 in here because, I don't know, it looks ugly to have like some number like that. Okay, so then what do I do next? Well, I'm going to put everything back into the equation, but in terms of u, right? So this in here equals to 3, and then 1, and then u, and then dx is du, right? And then if you remember this formula right here that we just learned, well, we know that the integral of 1 divided by something, d something, equals to ln of that something, right? So then in here we have x, but in my example, I have u, right? So I'm going to go ahead and replace my x in here with u, okay? So the answer that I'm going to get in the next second would be ln of absolute value of u plus c, okay? So then this in here equals to 3 because we do have a 3, and then ln of u and then plus c, right? And I keep telling you that we start with x, so there's no way that we're gonna end up with u, right? So then we have to substitute back the u for x, right? So let me just bring it out here. The final answer for that like small part, it is 3 ln of absolute value of x plus 1 plus c. Okay, so now that I have the answer for the blue part in here, let me just go ahead and copy this answer and put it in here. Okay, so together everything in here would be the final answer of this problem. Okay, and be careful that you don't have to use substitution for the whole problem, right? Like for this example, if you break it down into 3 parts, 1 part, 2 parts, and 3 parts. Notice that you only use substitution for the last part, right? Because the first integral is like easy, the second one is like tricky, is hidden. But then trust me, by practice, you're gonna get used to it. Okay? Only the last one is like tricky, it's harder a little bit. Okay, that's why we have to like bring it outside and do it. But yeah, you know, like calculus level, right? It has to be somewhat challenging, right? So then for your part, let's try this one, okay? For your problem though, it's easier because you don't have to do long division, right? But you do have to do something related to the last section that we did, okay? But if you have problem with this one, let me know, okay? So that's the end to the lecture today. I hope that makes sense. If you have any questions, please let me know. Thank you for your listening. Take care and have a great day. Bye-bye.